getting started with Python. I want to tell you what we're going to do. I've set myself some fairly ambitious goals for what I can get done with 6 lectures for beginners. I don't know that we'll get through all this, but to start with, I'd like to take you through the concept of variables and Python simpler data types in what I'm going to in the first module that we'll talk about. Then we'll go on to talking about some of the higher level data types and assignment variable, how we do assignments, how we put things into variables. We'll talk about expressions. Then we'll go on to file input and output. An important concept in Python is how you handle errors, and how you access. Python is a really rich language in the sense that it has lots and lots of features out there already written for you, so you don't have to do them yourself. So we'll talk about. I can't possibly cover everything that's in the Python language, but I can at least tell you how things work, where to find things, and so on. And then finally, since you're going to want to write your own programs, how to write and call functions. There's a lot more to Python that could be covered at this point, but I think that at that point the best thing to do is to get on with how one is going to use Python. So for example, the next thing we'll do is just how to do simple graphics. And then after that, we'll talk about how you use Python to control a beamline, how you talk to epochs, PVs, and listen to get information back. Finally, the last thing I would like to cover, I don't know that we'll get to this, but it'll be next on the list, is how you use NumPy or NumPy and SciPy. These are packages which are not distributed as part of Python at this point, although I've heard that soon a NumPy will be. But they're free and they do really nice mathematical and algebraic calculations very, very quickly in general. So, so after we cover these things, and my goal is that I have each one of these presentations is sort of a short module, and things are written that way so that I don't quite know how much we're going to cover in each presentation, but we can stop whenever we get to a good point. The slides that I'm going to show you will all be up on the web page for the PIG, the Python Interest Group, as soon as you can get to that, right? Yeah. Okay. Let's see. Anyway, later, I don't know exactly when we'll get back to this, but probably sometime in June, we'll start up again. We'll present some more higher level Python work because to work with graphical user interface programming, you really need to understand Python objects. Now, if I were a computer scientist, I wouldn't have let you start getting programming without getting to Python objects, but I think that there's an awful lot you can do without having to understand how to create an object. Also, there's a lot more about functions that we're covering that I'm not going to cover. That point, we'll go on to doing graphical user interface programming and also how to do graphics, scientific graphics, and graphical user interface programming again. I'd like to spend some time on good programming practices. Another thing that I'd like to really encourage people to think about doing with their Python programming is using databases. And MySQL is a interface to a free database protocol, and I can tell you firsthand when I was working on setting up programming for 11BM, it really came in handy that there was a nice interface between Python and MySQL. Okay, some references. This will be in your notes, but this is a good, very basic, very introductory book for getting started with Python. You may not want to think like a computer scientist, but it's of some use anyway. And the nice thing about it is that if you don't want to buy a personal copy, you can either read it online or download a PDF version of the book. Let's see. I personally learned Python from using a book by Mark Lutz. There's another book out there that's also accessible on the web called Dive into Python 3, which, did you look at that one, Debbie? What did you think of it? Okay. Okay. It's also available on the web. The only disadvantage with that book is that there are some subtle differences between Python 3, which I'll come back to and talk a little bit about why. There's a lot of resources on the web. If you find me incomprehensible, there's another set of lectures on the web in software carpentry that you can go through that will introduce Python. There is a Python tutorial on the main Python website, and that same Python website has a complete documentation. I find that I don't find the Python documentation on the language itself to be very useful, but when it comes to the modules and things like that, I think it's pretty good. All right, so why Python? Well, Python's a scripting language. I've been doing computer programming back through when I started. I used computer cards, and I will say that scripting languages really change the process of programming. You can develop code with a scripting language much faster, at least in my opinion, than you can in any other environment. Scripting languages have very nice error handling. You can test code out at the command line. You can type it in and see what it does line by line if you want to. Python's free. The disadvantage of Python, or scripting languages in general, is that you have slower execution time than you would in a compiled language like C or Fortran. But I'll comment that for a lot of purposes, it really doesn't matter how fast code runs. If you're doing something, you're setting something up on a graphical user interface, and you press a button, and it has to do a computation, if it takes 10 microseconds or 100 milliseconds, it still comes back just about instantaneously. So while this wasn't true back in the days of computer cards, when you paid for your computer time, to a large extent, for many things, processing speed is not as important as how quickly you can get the job done. Finally, because Python has some really nice packages, you can do things really quickly if you want to, if in many cases. And if you need to, you can use C code or Fortran code so you can get the speed you need if you want to. So Python also has very nice packages. I mentioned NumPy and SciPy for doing linear algebra, all sorts of scientific computations. You can build really nice graphical user interfaces. I'll talk about using this WX Python package, but there's another alternative, PyQt. Python actually comes with a graphical user interface built in called TK, which I don't recommend. There's some really nice, powerful plotting packages. You can do 3D visualization, and it offers you access to EPIX controls via 2 different packages. So to give you an idea of what you can do with Python, I wanted to show you a very simple example. So here is effectively a 9-line program. If you ignore the comments, the first 3 lines, and don't worry about the syntax here, but just to tell you, first 3 lines are just telling the language what packages to call in. What are we going to need? We're going to use NumPy, we're going to use a section of SciPy, and we're going to use matplotlib. And then in these 3 lines, we compute a Bessel function, the J0 Bessel function. It's only 3 lines. 2 of them, and 2 of them are doing this, setting up a grid and calculating the square root. And then finally, these 3 lines do generate this plot. So that's an awful lot that we can do in just a very small number of lines of code. And actually, I think I'll show one more example of the same code. But let me try actually showing it to you live, because it's much more interesting that way. All right, so here we go. So I'm just going to actually, let me just show you the script first of all. So here is another version of the same script. It's actually, I've got exactly the same information, except here I'm calling a different graphics library, and here I'm using different graphics commands. And let's just run that. It takes a moment to start because it has to pull up a fair amount of things. But it will do the same plot we saw last time, but it'll work in Mayavi, which is a 3D visualization system. So, okay, so that's the Bessel function. Looks much more impressive that way. And you can see that we can rotate it and move it around in 3 dimensions. Is that free as well? Yes, it is. Yes, it is. It is free. Okay, so so that's what we did just there. Much more impressive to see it move around than it is to see a static image. And by the way, I should mention that everything here runs exactly the same in Windows and Linux and the Macintosh. That's one of the really nice things about Python, is that except when you get into a little bit of graphical user interface programming where you may find some very subtle gotchas from one platform to another, pretty much everything is works the same. Now, this isn't what I would like to put up, but it is true. The Python was written, oh boy, about 15 years ago, I think. And in the meantime, the developers of Python rethought some of the things they did. And they decided they would make some subtle changes in the language. And they decided to make that difference effective in Python 3.0. Almost nothing that I will present to you is different between Python 2 and Python 3. But there'll be a couple places where I will say to you, this is the way you need to do it, or here's something that is potentially a problem. I'm going to continue to work with Python version 2, and Python 2 is still being updated. The latest release came out perhaps weeks ago, partly because some of the add-on packages are still being developed to work with Python 3. BCDA, if you're going to want to do programming with epics in the BCDA CAUtil package, that's still at a version of Python that's about 5-6 years old. And I don't really have the experience working with Python 3. It's a little easier on some computers than others, but on the Mac it's a little bit difficult to have multiple versions of Python. So I haven't been playing too much with Python 3. Yes?
Is the issue a lack of backwards compatibility, whereas if you put your 2.x things into 3 they don't run, or more of the environment you find yourself in as a program?
Okay, there are some fairly significant differences under the hood. So if you're going to write your own C-level package to work with that would run in Python, there would be some incompatibilities. In terms of the code, there are some things in Python 2 that will not run in Python 3, and almost everything that will run in Python 3 can be run in Python 2.6 and later. Unfortunately, that's not true on the beamlines, because that's stuck at 2.5 for the immediate future. Then, okay, all right. So, and I put this link here. It's about a 4-page compilation, but it goes through every little detail about what's different between Python 2 and Python 3. But as far as I know, everything that we're going to see in here will run in Python 3 without any changes. Okay, so how do you get Python? Well, Python is available on the web. You can download it in from a bunch of different places. The problem, though, and I don't know that there's a good solution, is that you don't want just Python. You want Python plus some of these other things like the graphical user interface. You'll want to get and so on. And so one of the things that we are doing is if you would like to download Python for any computer that you're going to find around here, there is a company called Enthought that has a $200 distribution of Python plus everything you could ever think of, that you can the Software Services Group has just purchased a fair number of licenses for the APS, so people can get a free license for that. If we go over the licenses, we're going to ask for cost codes as part of this, because if we go over the preset number of licenses, we will start needing to charge for the purchase of additional licenses. Yeah. That's correct. You're paying for the packaging. What's that? You're paying for somebody going through and compiling literally something like 100 or so packages individually, making sure that they all work, that they're all compatible, putting out upgrades and so on, and making sure that they have it available on, I think it's 8 different platforms. I believe they support 64-bit and 32-bit on a bunch of different platforms. So, you know, I mean, I would love it if they would make it available for free, but that's not their business model. They do have 2 competitors. There's a distribution called Python XY, which is free and includes most of the same things. Python XY is available for Linux and for Windows, but not for the Mac, and not also for Solaris. And there is another company called Active State, which also has a distribution. My life is short, so I haven't had a chance to play around with all of these. I can tell you that Python XY works reasonably on Windows because I've tried it there, but I can't speak to anything else. All right. So running Python, couple different ways of running Python. We saw one example. We just type Python followed by the name of a script, and it runs that. So the canonical first program you ever write is "Hello World," and so here's an example of a session which, if I were more brave about typing in front of an audience, I would just do for you. I start up Python, and it comes back, tells me what version I'm using, and this was done on a beamline computer, so it's Python 2.5.2, and that is where I get a prompt that says where I can type something. So I type in print hello world, and it comes back and types and responds by executing that command and prints out hello world. If I put the same information into a file, so here's a file that contains that same information, I can display it, and then I can run Python by saying Python followed by the name of the file, and it will run that. Now, if you want to do more advanced things, you can set up a shortcut, for example, on Windows that would do the same thing. So you would have a little icon that would open up a DOS box and display hello world. But the point I want to make here is that Python's very easy to run, and you can try your commands out one line at a time if you want to. If you're going to do that, though, you're going to find that it gets pretty tiresome quickly. So if you're going to be doing Python development, for example, where you want to do MATLAB type things, where you're going to calculate something and then plot it, see if that's right, calculate it differently and plot it or something like that, then there is a shell called IPython. Maybe I'll show that a little bit later. If you're interested in having a development environment, there is something called idle. You'll get a hint of where that name comes from in a moment. That is distributed usually as part of Python, but it's not an APS share. I haven't had a chance to work with this myself, but Pete Jemian gave a presentation on how to use something called Eclipse with a module underneath it called PyDev. And that's a really sophisticated development environment. And he gave very complete notes on how to get it set up. So I really recommend that you look at that and think about it. People who know Emacs and love or hate it will find Python is a good. You can do Python development in Emacs. Another IDE, which a number of people who develop Python code quite a bit like, is developed by a company called Wingware, and they offer a free stripped-down version called Wingware 101, which is actually, I think, meant for classroom teaching. So those are different environments where you can type Python commands and see what's see what's going on. The better ones, like Eclipse, give you a place where you can actually run code. If you have a long script, you can run it up to a certain point, look at what's going on, continue it. It's called putting in a breakpoint. I recommend at least looking into the Wingware. Actually, the first one that I would look at is Eclipse. I really think that that's probably the most powerful one. But having said that, I haven't taken the time to do that myself yet. Okay. If you're not going to use one of these integrated development environments, don't use Notepad to develop Python code. Okay. You'll see why when we get further on in talking about Python. But Python can be really particular about putting spaces in the right places and things like that. And you'll waste a lot of time. There are much of editors, for example, for Windows that are free, that you can use for developing code. And this web page over here has a very long discussion of the pros and cons of various editors, some commercial, some free for various platforms. Yeah.
So for a beginner programmer,
Mm-hmm.
usually sometimes an IDE can really help.
Yep.
Do you recommend any one of them for command completion stuff?
I think that Eclipse with PyDev is probably the one that I would look at. I think that that's probably the best choice. I think the Wingware product would be probably number 2 on my list, but I'm a little uncomfortable saying that because I don't use either myself. But and I keep saying one of these days I'm going to get around to learning to use the Eclipse PyDev because I was really impressed with it. But I just have to say I don't use it myself, so that's why I have that comment there. That's probably what I would start with if I were, but I don't feel comfortable saying, giving it a formal stamp of endorsement. Okay, so Python trivia. You might be wondering where the name comes from. First of all, it was developed by a person with both a mathematics and computer science background named Guido van Rossum. He now works for Google and Google's quite interested in Python. Let's see. He is no longer the sole person producing Python, but the very many people who are working on Python in its continuation and its continued development have named him benevolent dictator for life. And when there are conflicts as to where Python should be going, he really steps. He often is the person who steps in and says, "Okay, this is the way that Python will go for the future." Let's see. And if you're interested, the name does not come from the snake. It comes from Monty Python's Flying Circus. I suspect some of you that may not know what that is, but anyway. Okay, so homework. Okay, we'll talk about this in the next class, but actually in this homework there isn't a whole lot to talk about, but figure out what distribution of Python you want to use. If you don't have, actually I should show you how to install Python. Have it installed. If you live under IT's rules, actually you might be able to, depending on what type of operating system you're using, be able to get away with installing it yourself. Figure out what editor you want to use or IDE, and get that installed as well, because you're really going to need to do those things. So let's see. I don't know why this is saving the auto recovery files, but yeah, question. 2 questions. Go ahead. Yeah. Oh, okay. Not a question. Another question.
I saw earlier you mentioned that Python comes on the Mac.
Yes, it does.
Does that mean that if I have a Mac, the first 4 steps are done?
Well, you don't have all the Python packages, but it'll be enough to get started with.
Some sort of IDE?
And there is not any IDE that I'm aware of.
So I can type Python and I get it done from him.
Yep. Yep. You might even be able to type IPython. I'm not even sure. Okay. Yeah. Was there another question? Yes. Yeah. I believe that they have the idle IDE built in, but they don't. But which is not probably my first choice, but it's there. You know what? I don't have a big enough desktop here to show you even this really skimpy Windows version. But well, you know what? Maybe I can try this anyway. Let's see. It doesn't take very long, at least, to get started. Okay. So let's see. Will this? No. Let's see. And unfortunately, I can't bring this. Well, anyway, we can try. I can just try showing you what it takes to install from nthought. So I've downloaded the distribution, which is pretty big. I think it's 250 megabytes. So it takes a little while to download. And let's get rid of that. I don't care that it thinks that my computer is at risk. So it's going to ask me just a couple questions. If you don't have system privileges, I guess in Windows that would be administrator privileges, you might be better off just installing it for your one user. And you can use a demo version of this, and hopefully within a couple days we'll have the mechanism for using the licenses for nthought set up. I should mention that it's licensed 2 different ways. We have licenses that are by person. If you get a license issued to you, you can install it on all the computers you use personally. But nobody else should be using it on those computers. Alternately, we have licenses for specific computers or cluster nodes. So if you wanted to install it on a beamline computer, however, I should point out that in terms of beamline computers, there's already a version of a reasonably complete version of Python already there. Just old. Yep. Sure. Mm-hmm. Mm-hmm. Yeah, you can I found it depends also what platform you're using. You can go out and get either binaries of each package that you want to use and install them. You can also compile them all yourself to install them. So it really depends on what you want to do and how far you want to go. So is there a difference in terms of performance? Actually, yes. If it turns out that this nthought distribution has some libraries for SciPy and NumPy that will use multi-cores if you turn it on. So if you really care about that performance issue, there is an advantage to working with nthought, but it's a pretty small one for most people. So I don't know that I'm mentioning the nthought distribution just because I know it works, but on the other hand, for anything other than a Macintosh, I think Python XY is a good choice. Many Linux distributions have it, as you built in, so it really depends a little bit on what packages you want to use, and so on. Everything that I'm going to show was already installed and will already work on the beamlines, for example. Okay, so just in terms of getting started, so this is all that's necessary to do, and it's going to start installing stuff, and it takes a little while. And in the meantime, while this is going, we'll come back to it in a bit, but I'll start on the next talk. All right, so let's go on to the first. Actually, I'll just wait until it gets started loading the packages. Okay. Yeah.
In terms of platforms, do you have a recommendation for a platform?
Which platform should you develop on? I would say that you develop on whatever platform you're most comfortable with. Okay. I prefer working on the Mac. I think that Linux is a great place to work. I think that Windows works fine too.
What about developing on one and then trying to use your work on another?
Okay. My feeling is that with the possible exception of graphical user interface development, when you develop on one platform, you can take that file and move it over to another platform, and it will run right away. No problems.
If you have a different, are there any IDE specific type things? Or are you using Flux, or using, some environment on one and then you go to the other?
Okay. Yeah. The question is there a way that you can? Are there any gotchas out there? And in terms of developing, there are definitely some packages which are specific to a particular platform. They're not commonly encountered, but if you're doing some fancy Macintosh stuff, you might choose to use a Macintosh library that isn't going to be there for anything else. The only thing that I can think of that I've come across is some very subtle things in terms of graphical user interface programming where a button just doesn't, you style a button and it just doesn't look right on another platform. Or another example where I've seen problems is that there's subtle differences in how graphics might work, or fonts or things like that. But in general, if you don't, if you're really doing if you're doing graphical code development, you probably do want to test out on different platforms.
But basically, if you write something on one and move it to another,
It's pretty much going to work. You have to do something pretty unusual before it's not going to work. So that's all that's necessary to get this started. And let's see, and down off the screen, which I can't get to, is my, oh, there it is, I'm sorry. So this icon that it's created, PyLab starts up Python, and it's noticed that I've just got a fresh new installation, and now I'm typing. Now this PyLab this will make more sense when we start talking about the SciPy and NumPy packages, but we can do things right away. For example, if I can just call a plotting routine. So I'm going to plot, actually I should just show you, range 10 gives me the numbers from 1 to 9. And I'm going to save that because I can't type that twice in a row without making a mistake. And I can say plot x comma x. And, okay. Why didn't it give me... Okay, that's interesting. I'm not quite sure why it didn't bring up the PyLab. Let's see if maybe I have to exit and try that again. It's possible that my screen resolution in this case is... here we go. Could not be imported. That's why it's not doing it. I think that's a screen resolution issue. Okay. Well, anyway, I'm not going to try to figure out what the problem on that is. All right. So let's go on and actually I'll just show you here the same thing because I know that's going to work. All right. So okay, plot x comma x. Oh, okay. Yeah, I know it'll work, but remembering to do the right things. I have to tell it I want to use PyLab. And now okay. So there's my plot of x against x. It's got SciPy here for me, so I can calculate the square root on the whole array in one line. So let's plot now x comma y. Let's make them open circles, and we'll make them red. So now I've got that plotted as well.
When you're doing that square root on the array, that's happening in compiled.
It's happening in compiled code, and it's happening very fast, and it would do it very happily in about the same observable speed if we gave it 10,000 numbers. Let's try it. Okay. Okay. All right. So let's go on.